1988 for the first time. So I guess when the book was being written, they were known. Because, yeah, as soon as they were discovered, even though they thought it might be like the Russians doing something, turns out that they're obviously a very natural event. And also, if you remember my other discussions on gamma ray bursts or GRBs, they are nature's most exotic particle accelerators, basically. Like, the theories about them is that certain particles, both leptons as well as hadrons, or basically like baryons, protons, things like protons, are maybe accelerated um, greatly in an environment like a gamma ray burst. And so certain processes are hypothesized for an environment like that, which is good for us to kind of probe and stuff like that if we did see gamma ray bursts. So yeah, 1967 they were discovered. Steven Spears was 2. There you go, Steven. Old enough to understand gamma ray bursts. But yeah, that's cool. Okay, thank you so much for the likes. Can we get 2 more likes so that we get 20 likes, please? That would be amazing. But yeah, so in fact, bursts of gamma rays from space have been detected by satellites originally constructed to look for violations of the Test Ban Treaty. So because he's writing this in 1988, it's been some time since the initial discovery of gamma ray bursts, but it took some years to really understand them and for people to really theorize about gamma ray bursts and understand what could be the processes going on inside the gamma ray bursts. And even now there are certain things that are kind of like unknown. So I could see how when he's writing this book, especially for the first time in 1988, not everything would have been known by then. So these seem to occur about 16 times a month and to be roughly uniformly distributed in direction across the sky. So this they already knew. The fact you get roughly 16 of these a month and roughly uniformly distributed in the sky, meaning that there's no particular direction they seem to be coming from, meaning isotropic distribution. They're coming from very far, far away, and it's sort of that we're randomly seeing, they happen far away. We randomly see some type of thing. It's not a certain particular source, say, in the galaxy that's producing these. So this indicates that they come from outside the solar system, since otherwise we would expect them to be concentrated toward the plane of the orbits of the planets. The uniform distribution also indicates that the sources are either fairly near to us in our galaxy or right outside it at cosmological distances, because otherwise, again, they would be concentrated toward the plane of the galaxy. In the latter case, the energy required to account for the bursts would be far too high to have been produced by tiny black holes. But if the sources were close in galactic terms, it might be possible that they were exploding black holes. So in general, we know that gamma ray bursts actually occur quite far away. Like most gamma ray bursts that we have in the catalog of gamma ray bursts, there's a gamma ray burst monitor. There's a catalog of gamma ray bursts that you can find from every year. They occur quite far away. Stephen Hawking is interested in this book in the ones that may or may not be potentially maybe coming from primordial black holes, if such a thing were to exist, and if such a thing were to happen to give off gamma ray burst like during our lifetime, etc. But in general, we know that gamma ray bursts, most of them happen very, very far. Okay, so again, so in the latter case, the energy required to account for the bursts would be far too high to have been produced by tiny black holes. So most likely they're from other reasons like supernovae. Actually, we know that long gamma ray bursts are, at this point, we know more about gamma ray bursts generally. The long gamma ray bursts, which are longer than the typical 2 seconds long, could be a lot longer than 2 seconds. those gamma ray bursts are associated with